Hello and welcome to our next section in our quadrilaterals unit. We're talking about properties of a parallelogram. So we have to define what a parallelogram is, and it has specific properties. So go ahead and get this down into your table of contents. Go ahead, also get this title down for this particular section, and let's get started. So a parallelogram. What is a parallelogram? Well, it's as we know, it's a quadrilateral where, and it's often drawn like as so, kind of like a slanted rectangle. Now, by definition, a rectangle is a rectangle is a parallelogram, but we'll get into that later. It is a quadrilateral with both pairs of opposite sides that are parallel. Okay, and that's pretty much it. So if we have, for instance, if we have a quadrilateral that we show, hey, these sets of sides that are opposite of each other are parallel, as well as these pair, then it qualifies as a parallelogram. So if we could call this parallelogram A, B, C, D. Okay? Now, if it is a parallelogram, just like we have above, it has 5 specific properties. Okay? If a quadrilateral, so notice that starts off if, just like a proof would, or a reason. If a quadrilateral is a parallelogram, then I'm going to put ... These 5 things are true. Then these 5 properties of parallelograms are true. Kind of like how we had if parallel lines, then these 5 angle pair relationships are true, or if, like alternate interior angles are going to be congruent, or same side interior angles are supplementary. These come up again in this particular unit, and it's used to prove some of these true. So these 5, then these 5 properties of parallelograms. And then I'm going to put this in parentheses, are true. And this is always true. So, first one. Both pairs of opposite sides are parallel, which is the part of the definition. So here we have it. If a quadrilateral is a parallelogram, then both pairs of opposite sides are parallel. That will always happen if you name something a parallelogram. Second one, then both pairs of opposite sides are congruent. What would that look like? Well, if I put tick markers on A and D, as well as AD and BC, AB would be congruent to CD. So we have that as well. I'm going to draw them off to the side here, just so we can visually see it on individually. So both pairs of opposite sides are parallel. We already have it above, but I'm doing it separately. We also have both pairs of opposite sides are congruent. I'm going to tick mark here, 1 tick, and then 2 ticks. So if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. Okay. Third one. If a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. Well, that would mean, for instance, angle A would be congruent to angle C. B would be congruent to angle D. Okay? And let's draw that here. Opposite sides would be congruent. 2 ticks, 2 ticks. Okay? Fourth property. Then consecutive angles are supplementary. This one should actually make a lot of sense, because if you have parallel lines, two sets of parallel lines, actually let's use a thicker highlighter. Let's go blue. One set of parallel lines and a transversal. We should recognize that these are consecutive angles. Let's use green actually. The green angles are consecutive angles, and notice that they are same side interior angles, and we know same side interior angles are supplementary if you have parallel lines. So this should actually make a lot of sense. Now we should also recognize that we have another pair of parallel lines. If we looked at it from the purple's perspective, and then blue being the transversal, then these two angles would also be same side interior angles, because they're on the same side of the blue transversal, and they are interior of the purple lines. So these two would also be supplementary. So all consecutive angles are actually can be supplementary. These would be supplementary, as well as these would be supplementary. And you go all the way around the horn, these would be supplementary, these would be supplementary. So I'm going to go ahead and erase all of this. Consecutive angles are supplementary. This one's going to be a little bit tricky to draw, so I'm going to actually use. Let's go ahead and draw it. It's going to be exactly like the drawing above: 2 ticks, 1 tick, 1 tick, 2 ticks. But then I'm going to put 180s all around. These two add up to 180. These two add up to 180. Consecutive angles all add up to 180, because they're all same side interior angles. Okay? And then the last one. Diagonals bisect each other. This one's a little bit of a weird one. What this says is if I were to draw two diagonals, okay, and I, for instance, said BD had a length of 20, and then this one had a length of 30, AC, then it would break down to 10 and 10, 15 and 15. In other words, they bisect each other. They are cutting each other in half. An easier way to show this is to just put tick markers, okay? So for instance, I would put 1 tick to show that this point in the middle is bisecting, or the midpoint of BD. It is also bisecting, or the midpoint of AC. So there, it is a bisector. They bisect each other, okay? So we could draw that in our little mini version here. I'm going to do this a little bit lower because that 180 is in the way. Do two diagonals, and I'm going to use a blue here just to kind of illustrate this a little bit better. 1 tick, 2 ticks, 2 ticks. Okay, and there we have it. If you have if your quadrilateral is a parallelogram, then any one of these can be marked as true, and we use them to actually solve for parts of parallelograms as needed. All right, so if you do have any questions, please let me know, and I will see you in the next one.